Okay, today we're going to talk about key features of linear equations or linear functions. And particularly, we're going to talk about when we're dealing with the slope-intercept form, y equals mx plus b. So when we look at this first example, we have y equals negative 3/2 x plus 1. In particular, we're going to look at the slope, the point on the line, and the x-intercept, the y-intercept, and finally we're going to put it together in a graph. All right, so here's the first thing. All right, we're going to look for our slope. Recall that when we're dealing with slope-intercept form, y equals mx plus b, our slope is given by our m, which is the number in front of our x, also known as the coefficient of x. All right, the coefficient of x. So when we look at this example, y equals negative 3/2 x plus 1, the coefficient of x, or the number in front of our x, is negative 3/2. So for our slope, we write m equals negative 3/2. Now to find a point on the line, what we have to do is plug in anything we want into x. And you may say, why x? Because x is the input. So we plug in what we want. Let's say, for example, we plug in 2. All right, this becomes y equals negative 3/2 times 2 plus 1. All right, and from here, now that we have an input, we have to determine the output using the order of operations to simplify this equation. So negative 3/2 times 2 plus 1 is what we want. Remember, negative 3/2 is the same as negative 1.5. Negative 1.5 times 2 is negative 3. And so negative 3 plus 1 gives us negative 2. Therefore, our point on the line, when x is 2, y is negative 2. So the point on the line is 2, negative 2. All right, that's our point on the line, 2, negative 2. All right, so we have our slope, we have our point on the line. Now we're going to find the x-intercept, which is defined as when the graph crosses the y-axis. All right, remember, this is our y-axis. Y-axis here goes up and down. I'm sorry, x-intercept. We're on the x-intercept. My apologies here. I'm sorry, we're on the x-intercept. So we're looking for where the graph crosses the x-axis, or we find the value of x when y is 0. All right, or we find the value of x when y is 0. So we're looking on left and right. The thing is, we don't have a graph. So what we have to do is actually plug in for y0 and solve for x. That's what we're going to do here. Again, we're going to plug in y as 0 and then solve for x. So here we go. 0 equals negative 3/2 x plus 1. In order to solve, we use the reverse order of operations. So instead of starting with parentheses, exponents, multiplication, division, then subtraction and addition, we start with subtraction and addition, get rid of that, and then go to multiplication, division. So we subtract 1 from each side here, and we end up with negative 1 equals negative 3/2 x. All right, from here, we have to multiply each side by 2, so that we end up with negative 2 equals negative 3x. Finally, we want to solve for x, so we divide each side by negative 3, leaving us with x equals 2/3. All right, x equals 2/3. So this is our x-intercept. All right, now we're on to the y-intercept. All right, now we're on to the y-intercept here. All right, which is the point where the graph crosses the y-axis. Or we say, find y when x is 0. So that means we substitute in for x 0 and solve for y in this equation up here. All right, in this equation up here. All right, so this becomes y equals -3/2 times 0 plus 1. We simplify it, and -3/2 times 0 is just 0. So we have y equals 0 plus 1. 0 plus 1 is 1. And there we go. So the y-intercept is 1, or the point is 0, 1. All right, 0, 1. So with all of this information, we know what our y-intercept is. We know what our x-intercept is. We have a point on the line, and we have the slope. So we can graph. All right, so let's start with our y-intercept is 0, 1. And then our x-intercept is 2/3. So it's just shy of 1. All right. Our point on the line is 2. So 1, 2. So 2, -2. And then we have a slope of -3/2. That means that we start at our y-intercept here, and we go, -3 is like our y. So we go down 3, 1, 2, 3, and then we go right 2, and we already have that point. So then from this point, we can go down 3 more, 1, 2, 3, and right 2. We don't have to do this. We technically have enough points to draw a line here. Put all our points together, and we have a graph. We have a graph. Let's shoot for this next example. We have y equals 2x minus 4. All right, note the first thing we want to find is the slope of this example. Remember, the slope is the line in front of our x. So we have a slope of 2. A point on the line, we can plug in anything we want in for x to get an output of y. So let's say that for our input, we use 3. All right, let's say we use 3. So this becomes y equals 2 times 3 minus 4. Remember, we can plug in anything we want for x and then simplify. So 2 times 3 minus 4, that's 6 minus 4, which is 2. All right, so the point on the line, when x is 3, y is 2. So this is my point on the line. All right, this is my point on the line. All right, for my x-intercept, don't forget we find x when y is 0. Therefore, we substitute for y in this equation. We're going to substitute 0 and write 0 equals 2x minus 4. I'm going to show the work here because I have the space to. Basically, the reverse order of operations, we add 4 to both sides. And we have 4 equals 2x. To solve for x, we divide both sides by 2. And x is equal to 2. So here is our x-intercept. Finally, to find the y-intercept, remember to find y, we substitute x equals 0. And we sub it into this equation right here. So this becomes y equals 2 times 0 minus 4. 2 times 0 is 0. 0 minus 4 gives us a y-intercept of -4. We're going to put all this on the graph, and there we go. So y equals -4. That's 1, 2, 3, 4 from the origin. So here's the -4. X equals 2. We're on the x-axis, so left and right here. And where is x equals 2? We go right 2 from the origin. Right there. And then our point is 3, 2. So we go right 3 from the origin. 1, 2, 3, and up 2. And here's our point, 3, 2. We know our slope is 2, which is the same as 2 over 1. Remember, slope can be defined as rise over run, which means from any point, we can go up 2 and write 1, and it'll be a point on the graph, since the graph has a slope, or the equation has a slope of 2. From here, we just connect the points with a straight line, which may not be so straight. All right, and there we are. I'm going to save this last example for in class, but all you need right here is in these 2 examples. Make sure that you copy it, make sure that you study it, and bring it to class.